Okay, I just wanted to give credits to the individuals who are really working with me to make this committee successful. Professor Wei is acting as a secretary. Professor Weiss is our tech liaison number. You all know the importance of a liaison with TAC. So the motivation of our work is listed here, but I think the entire point, you can read the slides, this is not the issue. The issue is that we really are facing a global issue for which we have a global goal. And the global goal is to provide the communities with means really of conserving fresh water. This is the entire issue. The committee mission is listed here. Actually, this is an updated mission, thanks to Professor Jackson, who made some suggestion, particularly in the second part of the sentence. But as you can see here, we intend to develop a report and information on concrete made with brackish, saline, brine water, and associated aggregate to improve this material system and give you the ability. So the membership of the committee to a month ago was as follows: 27 voting members, 13 associate members for a total of 4. In the last 2 days we added 2 new members in terms of voting, so we are at 29. So for a new committee, this is kind of impressive, I believe. As I mentioned before, this is a global issue, and as a global issue, it requires a global perspective, and collaboration with others is of fundamental importance. So we have a liaison with the Asian Concrete Federation, why ACF? An incredible amount of work is being carried out by colleagues in that region of the world, and in particular in China. The motivation is very interesting, is construction at sea, but not only construction at sea where there is no availability of fresh water, but also in places like Hong Kong for the conservation of the fresh water. The other level of collaboration that we have is with an activity that started in the Kingdom of Saudi Arabia and is the Novus Crete Consortium. The presentation that will happen after mine, we switch the order to give time to colleagues to upload it. So the presentation on Novus Crete will be following mine, and it will give you an opportunity to understand how important this activity is, particularly with the objective, the clear objective, to come to the deployment of the technology and the development of the tools, specification, standards that allow the use of this material. And finally, and at the panel we will have Professor Sutter here with us, we are trying to establish a collaboration with ASTM C9, and in particular Subcommittee 40, the ready-mix concrete. Drs. Lobo and Wilson are the individuals who are key to hopefully allow us to bring the seawater inside this spec C1602 that is a purview of this committee. So very important activity, as you probably recall. Okay, so I'll keep on talking here. It's very important that you realize the role of ACI versus ASTM. ACI generates documents that are related to engineering and construction. The role of ASTM is material specification and test methods. Therefore, if we have to develop a specification that speaks to the issue of seawater, then that specification is more on the turf of our sister organization called ASTM. The first objective of the committee is to develop a state-of-the-art report. This is a snapshot of what the situation currently is in this space of seawater concrete. What you can see here are proposed title for the sections, the parts or chapters of the document. The committee met today and had a discussion, more than a discussion. I made a presentation on what the vision for the state of the art is, and shortly we will get to work on it. Okay, so what I showed you in the previous slide, I'm going to try to speed up. Thanks, John, for also staying up front, just in case we panic one more time. And so this is really I want to give you a quick look at where we are today. And this, again, speaks to that issue. I also want to make sure that you recognize the name of the individuals who have helped me in developing this very short presentation. Their names are listed there. Very interesting, some slides that give you an idea of the excitement with numbers. Data, we are data-driven, right? So Dr. Kodadadi just came up with this idea of looking at artificial intelligence and have a look at what are the documents available now in the free literature around the world. And as you can see, really, after, let's say, the year 2000, there has been an explosion of research and development in this area. And so this year alone, we are close to 500 documents. If you want to see where are the places where this research in particular is taking place, obviously you look at China. And the US is a distant second. So this is not an issue who is doing more and why. The issue is that there is a dramatic interest in a country, and that country is kind of leading the research, and that's why we also have a need for collaborating with them. These publications are subdivided in many categories, and the most relevant are the papers and the proceedings, and you can see that basically 2/3 are technical papers. In this slide you can see that the journals that are publishing the articles related to this technology, and as you can see, construction and building materials seems to be the one that is most receptive of documents related to this technology. I just, in the next few slides, and also in the interest of time, I'm just going to cut them short, but if you think in terms of what do we know now, and what are the issues that are relevant to this system that we now call concrete with seawater, these are some of the, let's say, issues that are of relevance to us. The first thing, if we look at the effects of seawater on cement hydration, I would simply summarize it the following way. It will expedite the setting of the concrete, so there is an impact on workability as well as setting time. So there is no doubt that the current literature has identified that. In the microstructure, there is certainly an effect on the microstructure of the concrete, and this is due to the presence of the chloride ions. And the formation of the salts is interesting because it changes the microstructure and has implications on the way that the concrete behaves, especially in terms of the density and the porosity of the paste. Some of these statements could be viewed as, I would say, not controversial, but not definitely accepted by all the researchers. So one of the topics of interest to us is to develop a mechanism to avoid controversial opinions, if possible, or whenever possible. The mechanical properties, what is the effect of seawater on concrete in terms of mechanical properties? Again, to summarize briefly, the early strength, because of that rapid setting, tend to be higher at 3 and 7 days, perhaps identical at 28. And then after that, it depends on the researcher. In some cases, we've seen increases, some cases the same, in some cases slightly less. Very interesting, the issue of the chloride binding. So we now inject chloride intentionally in the concrete because we're using seawater. What happens to them? And so this very interesting phenomena, the formation of salts, as you see indicated in the slide, the effect on porosity is obviously significant, but this doesn't mean that we can still use black steel. Okay, black steel meaning steel that is not protected, because obviously the corrosion will be the outcome of the use of seawater. The chloride ions remove the passivation of the steel even in an environment that is high pH, and obviously the result would be exactly that. More on chloride binding, the role, for example, of supplementary cementitious materials appears to be one of the interesting addition to the mixture in order to make it sustainable. One of the things that is rather difficult to identify in the state of the art today is the durability of this mixture. Okay, the durability, Dr. Jackson reminds me that sustainability and resilience may be more important than durability, or they include durability. But the entire point that we're trying to make is, if you are using materials that are non-conventional, you have an additional obligation to look at the durability aspects. One of the perhaps most interesting aspects from a research standpoint is sulfate attack in the presence of seawater. Because seawater, fortunately or unfortunately, contains some of these sodium sulfate or magnesium sulfate, and they have obviously an effect in terms of, let's say, reaction with the gypsum. And this leads us to the understanding that when we say seawater, we also need to be cognizant of what are the chemical compositions of the seawater. So seawater is a generic term. It's like saying concrete, but it is concrete and concrete. So there is seawater and seawater, and so we need to be very, if not careful, but cognizant that different oceans have different levels of, constituents in terms of different ions. So here more on sulfate attack, and very interesting, even though it's taken a, let's say, a secondary role, at least in this presentation, is also the use of aggregates that are directly taken from the seabed and utilized as sea sand. And the use of sea sand is not original, right? Because if you wash it, it's as good as the sand that we mine. But here, again, the idea is to be able to use sea sand without washing it. And you will hear in the next presentation, there is not only an interest in sea sand, there is an interest in desert sand. In other words, is all the materials that today we do not recognize as good constituents for concrete that we think have an opportunity to deliver something that is sustainable. Finally, some recommendation for future research. This is where the academic side of the world, but not only the academic side, but certainly also industry, and in particular some of the companies that focus on admixtures, we should be have some consideration of these items. So expand data on durability. This is key, right? As the, let's say, the trademark of sustainability is in the fact that we design for the future. If you were at the presentation just an hour ago at the international luncheon, the speaker at the question, how long would this tunnel supposed to last according to European Union requirements, 120 years. So 120 years has become the standard for the infrastructure in Europe, and I think this is a type of objective that we try to attain. We have to resolve some of the contradictory results. We'll be able to do it for good and forever, probably not, but certainly this is something that the research community is asked to provide some light. Optimize concrete designs, and this is again key if you want to move from the research to the implementation and field deployment. This cannot be done without specification. So the tools for the engineers and the specifiers have to be present, otherwise we will only work in demonstration projects. And then the last item, we certainly, concrete without reinforcement is like an orphan child, in my opinion, and obviously we need to look at reinforcement that are corrosion resistant. Would they be composite? Would they be steel with appropriate coatings? Or would they be the stainless steel? So this is what we are indicating to the research community being the gaps that we still have in order to make this technology suitable.